Hello, everyone. My name is Molly Halsey, and I'm the event specialist here at EDB. I will be your host today for our office hour on Postgres connection pooling. I'm joined today by Sunil Narain, EDB's Technical Director of Customer Success. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the questions panel. Now, without further ado, I hand it over to Sunil.
Okay, thank you, Molly. So hi, everyone. My name is Sunil Narain. I'm part of EDB's customer success team. And today in this office hour webinar, I'll be discussing connection pooling in Postgres. I'll also demo two popular connection poolers, pgbouncer and pgpool 2. And we'll also have a Q&A session at the end of this office hour. So with that, I'll go ahead and get started. So here's the agenda for today's session. We'll go over pooling introduction and would like to discuss why we want to use pooling. We'll go over some of the configuration and features of pgbouncer and pgpool 2. We'll discuss some architectural examples and conclude the session with a demo and Q&A. So what is connection pooling? Connection pooling is a way of maintaining a pool of or set of database connections in open state and reusing those connections from the pool when a new request comes. And after application or client is done with the connection is returned to the pool so that another application request can use the connection. So why do we want to do this? Because this gives us some advantages. First, we don't have to spend time opening and closing connection when application needs it. So it reduces the overhead of opening and closing the connections. And it also limits the number of connection to the backend database. As you know, every Postgres connections add some overhead. So we want to limit that overhead by reducing the number of connections to the database. Again, why do you want to use pooling in Postgres? It's because of Postgres architecture. The Postgres architecture requires that every time a database, every time an application wants to connect to the database, it needs to fork a new database process. And the reason for doing this is because we don't want one user or client to bring down the entire database. And the other reason is forking a process has become more efficient in Linux. The challenges with this architecture is because most of the modern applications tend to open and close connection rather than reusing them. So it becomes a problem when we want to fork so many processes in a short span of time if we are using very short transactions. And Postgres performs well when their number of concurrent connections are between the range of 300 and 400. And this we have found by doing a benchmark. One of our senior support engineer did a benchmark of a Postgres with the number of connections and TPS and latencies. And we saw that the latency is very low when we keep the connection counts between 300 to 400 range. So if you want to use more than, if you have a requirement to use over 500 or thousands of concurrent connections, please use a connection pooler. And pooling will also benefit even with a small number of connections because you will not be spending too much time opening and closing connections. So here are a few of the options available for connection pooling. You can rely on the language libraries such as you can use Java-based connection poolers, DBCP, C3PO, or Hikari CP. And if you have a .NET application, you can use the connection pooling provided by the .NET and pgSQL driver. But the problem with this approach is if your application is using multiple languages, how many connection poolers you're going to maintain? Then there is another issue that there is no centralized control of your connection pooler. So another option is to use middleware connection poolers. The advantages of middleware connection poolers are they can be placed anywhere. They can be placed on the application server or a database server or on a server on its own. The disadvantages of middleware connection poolers are that you have to, for authentication, you have to rely on the connection pooler. That may or may not be acceptable. And it's an additional component in your infrastructure that you have to maintain and manage. That might add some cost to your infrastructure. So we are going to discuss here two very popular connection poolers, middleware connection poolers, pgBouncer and pgpool, pgpool2, that are available for Postgres. So let's first discuss pgBouncer. So pgBouncer is a very easy to use connection pooler. It's single-threaded. Multiple instances can be run on the same server, but you need to use a different port, or you can run instances on different servers. Very simple to configure. Potentially a single point of failure if you are using just one instance of pgBouncer. It doesn't provide any inbuilt HA capabilities. So if you are using multiple connection pooler, you'll have to somehow check the health of multiple instances and then failover or provide HA on your own, because pgBouncer doesn't provide any kind of health check or HA. The authentication is done using a password file, user file, but you can use pass-through authentication. So if the user is not found in that user file, the authentication will be passed on to Postgres using a auth query. And you can control the privileges that are needed by the authentication account by defining a function, and that is outside the scope of this discussion, so I'm not going to discuss too much about that. So once the authentication succeeds, pgBouncer checks for the cached connections with the same username and database combination. If the cache connection is found, it returns a connection to the client. If the connection is not found in the cache, then it will create a new connection, provided the number of connections don't exceed any of the limits that you specify in pgBouncer configuration. So here are some of the features of pgBouncer. It provides 3 pooling modes. Session pooling. In session pooling, connection is returned to pool when client closes the session. And this is default pooling mode. In transaction pooling, the connection will be returned to the pool as soon as client commits or rollbacks a transaction. But there is no guarantee that the 2 transactions are going to, from the same client, are going to run on the same server connection. Statement pooling is where connection will be returned to the pool as soon as the statement is executed. You should be very cautious about using this, because this might cause a few issues with your applications, because there might be some challenges where you might want to, your application might want to use the same connection for the whole transaction, but a statement mode will not allow that. And then transaction spanning multiple statements are disallowed in this mode. So transaction mode is better for performance, but if you are using prepared statement, then use session pooling. Again, pgbouncer is lightweight because all the commands are passed through. Nothing gets processed at pgbouncer, so it maintains a very small footprint. It's very easy to set up out of the box. It can authenticate a user using the file, the user file, or you can also use the pass-through authentication. So pgbouncer doesn't have to maintain a list of the user, or you don't have to worry about updating the password in the file anytime user changes their password. And it can improve your TPS, transactions per second, and so it also provides some performance gains. Here are some of the configuration advices. If you are dealing with large number of client connections, please use multiple instances of pgpool. Plan for maximum of 20 or 30 connections per instance. Ensure OS is configured to support number of connections. So if you are increasing max connections in pgpool on max client connections, make sure that you also increase the file descriptor limit in your OS. Statement mode needs to be considered very carefully, and session and transaction mode should be used accordingly. Again, pgbouncer doesn't provide HA or load balancing, so you have to use some other way of providing the load balancing or high availability. You can use another load balancer, HA proxy, in the middle to provide the load balancing. Now we'll discuss pgpool 2. So pgpool 2 is much more advanced. It has many more features that are available in pgpool, and not all the features are used by everyone in pgpool 2. It provides features such as load balancing, connection pooling, replication, high availability, in-memory cache, and watchdog. Supports HA architectures, and it also supports read scalability. But you should, if your application can handle and can divide the read and write workload, you should use that first rather than relying on pgpool to do the splitting of read and write or load balancing of read and write workload, because in some cases it can prove to be unreliable. Again, since it can split, it can identify read and write workload, it can be useful as a load balancer and load balance your queries to your replicas, read-only replicas. It also provides an in-memory cache where it can cache the query results and the query itself in its cache. And when a user submits the same query with the same parameters, it will just return the result from the cache rather than running the query again on the backend database. So you will see some performance gains by using the in-memory cache or query cache. So pgpool comes with several running modes that you can use. The streaming replication mode, this is the most popular mode where Postgres is responsible for synchronizing the database using a streaming replication. This is widely used and recommended mode. Load balancing is possible in this mode. The second mode is native replication mode. In this mode, pgpool is responsible for synchronizing the database. So you will use pgpool to set up your replication. And this is a synchronous replication. Load balancing is possible in this mode. Then next comes the logical replication. Here again, the Postgres is responsible for maintaining the logical, or providing the logical replication and synchronizing the data. Again, load balancing is possible in this mode. You can run pgpool in Slowney mode, where Slowney replication is responsible for synchronizing the data. between your master and standby servers. This mode has been deprecated because Slowney has been deprecated, so this is not recommended. As per the documentation, it's not recommended anymore. Snapshot replication, snapshot isolation mode. This mode is considered experimental in pgpool 4.2. And similar to native replication, it adds visibility, consistency among the nodes. You need to set up isolation level to repeatable read in your Postgres instances to be able to use this mode. Then comes the raw mode, where it's a user's responsibility to synchronize the data, and load balancing is not possible in this mode. So I'm not sure how useful that mode is going to be, but it is there and available. So here is the architecture diagram that I have taken from the pgpool documentation. You can see that there is a main parent process that is responsible for forking child processes. And those child processes accept connections. There is a PCP process that is used for administrative and management tasks. And there is a worker process for detecting any replication delays. And if you are using pgpool in high availability mode, or you are running multiple instances of pgpool, you can use the watchdog feature of pgpool to check the health of the pgpool nodes and provide a failover capability using the watchdog. So again, as far as the configuration, if you're using all its features, pgpool is very complex to set up. By default, it will fork 32 child processes, which is controlled by num init children parameters. And one process is equal to one Postgres connection. And if you think about how many backend Postgres connection is going to make, you have to multiply that by number of, or multiply that by max pool size, which is by default, it's 4. So 4 times 32, that many, it can open that many number of backend connections. So again, you have to observe the maximum connection limit in Postgres when you are setting pgpool connection parameters. Ensure that OS is able to support a number of backend connections. And you should also understand the load your application generates to use the pgpool. If your application is always going to be generating write heavy workload, then just use pgbouncer. You don't have to use pgpool because you cannot use the load balancing feature there. So authentication in pgpool is done by pgpool itself, and you have to maintain a list of username and the password in a pool password file. Every command that you issue, it gets sent to pgpool, and then it gets processed at the backend database. So that's the reason pgpool is a little bit heavy, and it's not lightweight. It consumes some system resources. The recommendation is to not to run it on database servers because it can consume up to 20% of your system resources. We'll go over the architectural example where I'll show you how pgpool can be configured outside of your database node. So here are some of the architecture examples. This is an architectural example for pgbouncer, how to provide high availability for pgbouncer. Here in this diagram, we are running 3 pgbouncer processes on application server itself. There are 3 application servers, and there are 3 pgbouncer, and applications are connecting to local pgbouncer nodes. And these pgbouncers are making connection to your primary database. And we are also using a failover manager, EDB's failover manager tool to maintain the high availability at the database level, where failover manager will detect the failure of primary database and promote one of the standby databases to the primary database. And if we are using a virtual IP, it will also move the virtual IP to the primary database. So in your PG Bouncer configuration, instead of using a direct IP address to the host, you can use a virtual IP uh, that is pointing to the primary database. Now, here is a architecture for providing high availability for PG pool. In this architecture, you can see that application is connecting to PG pool using a virtual IP. And there are 3 PG pool nodes. They are running on a separate server, and Watchdog is also running. So Watchdog is monitoring the health of all the PG pool nodes, and Watchdog will make one of the PG pool node as primary node. It's not database primary, it's a PG pool primary node. So there is a distinction between them. So if the Watchdog process uh, finds out that one of the my primary PG pool node has gone down, then one of the Watchdog process running on the standby nodes will take over and make that PG pool node as primary node. And in turn, it will also move the virtual IP. You will have to use a failover command to move the virtual IP, but that option is there. So you can move the virtual IP to the new primary node so that your application is always connected to the PG pool primary node. And those PG pool nodes are connected to primary and standby databases. And primary and standby databases, they are managed by EFM, the failover manager. So if a failure occurs at primary node, failover manager will failover or promote one of these standby databases to be the new primary. So your PG pool will have your PG pool node will have the virtual IP. Your application will be connecting using virtual IP, and then PG pool configuration will be sending read and write workload to the primary and standby uh, servers. And here are the links from EDB's documentation that talk more about the high availability using PG pool and EFM. So what are the conclusions? PG Bouncer and PG Pool 2 both can tolerate network outages, database restarts, and even automated failover and control switchover. PG Bouncer and PG Pool 2 both provide connection pooling for Postgres databases on community and EDB advanced server. Both can be installed on Linux and Windows. They can be built from source or downloaded from repository. Using EDB failover manager with the virtual IP capabilities, connections can be persistent from manual switchover from master to standby during maintenance or during automated failover from master to standby using EDB's EFM. So here is the summary. Neither PG Bouncer or PG Pool will address all your needs. So you have to pick and choose what are your most important need. If you just need connection pooling, go with PG Bouncer. It's easy to set up, easy to maintain. If you need load balancing, go with PG Pool because it's also a load balancer as well as a connection pooler. PG Bouncer works well out of the box. It needs only few configuration parameters that you have to set, but it will require some tuning for high transaction systems. PG Pool has many settings, and those are some of those are complex settings. So there are many features, but with sufficient testing, you can use those features. Direct access to database or allowing access via a middleware such as JBoss may be suitable for some of the application. So if that option is available, use that. And the quiet failover is possible with PG Bouncer. And there is a blog available where one of our EDB employees have tested that how you can quietly failover using PG Bouncer. And that I will provide the link in the resources section. pgpool also has a watchdog feature that we discussed, that it can handle the virtual IP or web failover, and it also avoids the split bin type of situation. Setup of pgpool is complex and it has many potential points of failure. So be very careful when you are configuring pgpool. You don't want to run into issues where now all of a sudden your applications cannot connect to the database because of some connection limits. So here are the resources slide where I have provided all the links that that will be useful, and we'll share this presentation after this webinar. So with that, let's move on to demo. Okay. End the show. Okay. So I'm going to show you both PG Bouncer and PG Pool setup. And first, I would like to log into my PEM instance. If you're familiar with the EDB's tools, Postgres Enterprise Manager or PEM is a monitoring tool or database administration tool, which is just very useful when you are using all of EDB's tools, and it provides you a GUI where you can see all your database activities. So let me log into PEM, and then I will show you the demo. Okay, so this is my PEM dashboard, and I have several databases. These DB server 1 and DB server 2. This is the database. They are set up in streaming replication. So one of them is a primary database and another one is a standby database. So let me log into here and I can show you how you can get the information about which node is the primary and which node is the standby. So if I'm logged onto this database, and if I go to one of the PEM dashboards called a streaming replication dashboard, that will show me, and if I scroll down, it will show me the information that it is pulling from EFM or failover manager. So as part of this demo, I have also installed failover manager on my primary and standby databases. And there is also a witness node because EFM needs at least 3 nodes. Here you can see that EFM is up and running. I have, this is my standby node, this is my primary node, and this is my witness node. I'm not using a virtual IP because this is all running in AWS, and we don't have a concept of virtual IP over there. There are other ways you can use maybe Elastic IP or load balancer, but that's outside of the scope of this discussion. So let me go over to my terminal window. So here I'm going to connect to my terminal window, and I will also, sorry. So let me connect to my, so I have created a client machine, which is just running a PG Bouncer. You can call it an application server. This session has timed out, so let me start it again. Okay. It's going to take some time to time out. Okay, so now I will log back in. And you can see that this is the node where I'm running. This is my client node, which is not running a Postgres database. It's only running a PG Bouncer. And you can see that I'm running a PG Bouncer here. Okay, let me make it a little bit bigger so you all can see. Okay, hope it's visible. So here you can see that PG Bouncer is running, and we can go over the PG Bouncer configuration file. This is a PG Bouncer configuration file, which is very few settings that I have enabled. I have my database defined here. This is the host name, which is my primary server. If I was using a virtual IP, I would have just used the virtual IP here. But since I'm not using a virtual IP, I'm using the IP address of the host, this port number. This is the auth user that is going to do the authentication the first time when we connect to pgpool. And then here, I'm just using all my settings, default settings. I haven't done any user level configuration. This is my listen port, which is by default is 6432. You can use any other port, any available port. I'm not using TLS connections. And some of the connection settings here, authentication settings. So I'm using a pass-through authentication. So in my password file, I don't have my user ID. So when I connect to pgpool using my user ID, it's going to check in the auth file. And if the auth file doesn't have my user ID, it will pass on that authentication to Postgres. And this is the query. By default, it runs this query to Postgres to find the password for the user that is trying to connect. And then it will authenticate that user and allow the connection. So let's go ahead and connect to PG Bouncer using my user ID. Okay. So I'm just going to use my, since this is PG Bouncer is running on the same node. I'm not going to provide the host address here. I'm just going to provide the port number of pgpool. And it should be able to connect to the database using my user ID. Okay, so I'm connected. So now here I'm connected using pgpool, PG Bouncer, and I can run any command or anything. But before I do that, I'm just going to show you how you want to, how you can connect to the PG Bouncer console. So there is a PG Bouncer database that you can connect to. And you can, once you're connected to PG Bouncer database, you can run any of the PG Bouncer admin commands. So I'm just going to use the same user. Oops. Now it should be using Enterprise DB user because that's as my user ID is not the admin user. Okay, so now I'm connected to the PG Bouncer console and I can look at, I can run commands like show pools. Okay, so it will tell me, okay, how many pools are configured here. I can also look at servers, show servers, how many servers are configured. I can also look at stats. So these are all the admin commands that you can use when you are running PG Bouncer. Okay, so now let's start our test. So I'm going to run a pgbench test, and I will show you how it limits the number of connections. So I'm just going to open a query window here. I'm sorry. So I'm just going to do this. And I'm just going to, I just want to list the number of connections from PG stat activity for this user, where username is S Narain. So right now, okay, there is only one user that is connected, and I'm just going to run my pgbench test. Okay, so here is my pgbench test, where I'm just going to by default, the max client connections are 20. So maybe I'm just with pgbench, I'm just going to open 25 connection. Okay, but in my query, it should only show me 20 connections. So that will be a good test of connection pooling, that it's reusing the connection. So here you can see that it has only opened 20 connections. It will not, if I keep increasing number of connections here, number of client connections, it will still use 20 connections. Go with 30 client connections. And you can see here, you can run this query again. And here you can see the number of, it's limiting the number of connections to 20. That's default value. So that's how PG Bouncer works. Now let's go over the PG pool test. Okay. So I'm just going to shut down my PG Bouncer so all these connections go away. PG Bouncer. I think 1.5. Oops. Maybe 1.15. Okay. So now my PG Bouncer is not running. I shouldn't see any connections here. Okay, they are all gone. So I don't have any connections from PG Bouncer. Now I'm going to run my PG pool test. Okay. So first thing first, with PG pool, you need to always know that which one is your primary node. So I'm just going to go onto one of my servers where PG pool is running. And PG pool, by the way, PG pool is not running on my client machine. PG pool is running on my standby and witness node. So here, let me enlarge this. I'm going to run a PCP command to find out which is my current PG pool primary node. So this is the PCP watchdog command. When I run this, it will give me this output where it shows that this server where PG pool is running is my master PG pool node. It's not the database master, but it's the master PG pool node. So I'm just going to use this IP to connect to PG pool and run my PG Bouncer test. So I get the accurate results. So here's the, okay, so this is my client node, and I'm just going to run my pgbench test again, but this time I'm going to connect to the PG pool master node or PG pool primary node, and PG pool is running on this port 99999. Again, connecting to the test DB, username, my username, and I'm going to maybe open 10 connections. Okay, and this is going to just run 100 transactions per connections, and it's a select only workload, and I want to see that my connections are, my select statements are going to read and write, primary and my read only replica both. So that way we can verify that connection pool, load balancing is happening. So let's do this. So here again, you can go and run this query and see all these connections are coming. There are 10 connections. And this is my primary server. And if I run the session activity here, you can see all these connections. This is the session activity here. And if I go to my standby node, okay, I should be able to see the session activity over there as well. So here also you can see some connections coming. Okay, now let's go back to, okay, this is still running. Maybe we can here, maybe we can log into the PG pool and look at some of these statistics. So let's log into PG pool here. So I'm just going to log in as enterprise DB here. Oh, sorry. I'm just going to do this. PSQL, and I'm going to log into my primary PG pool node. The port number is 9999, sorry, 9. And database is test DB, user is enterprise DB. Type in the password. Now here I can just see I can run this command. This is a PG pool command, pool nodes. And there you can see that it has sent these many select statement to the primary node and these many to the standby node. So depending on your workload, there's not an equal number of select statement, but it has basically divided the workload and sent your select statements equally to both the nodes. So this is how load balancing works in PG pool. Okay. So with that, I will end the demo, and we can maybe go into the Q&A session and try to answer some of the questions you might have. Okay.
Yes, questions have been rolling in. The first question that came in was, can we monitor warm standby with Postgres Enterprise Manager?
Yes, you can monitor warm standby. The only thing is you cannot use the failover manager with warm standby because it needs to run queries onto the database. So yes, you can monitor your warm standby with Postgres Enterprise Manager.
Okay, great. Another question that we had come in was, in a replication scenario, should a replica use PG Bouncer for all connections, including replication connections? And then the second question was, are there any type of connections that should not use a connection pooler? And then some examples they listed: PG dump, PG base backup, replication slots.
Yeah. So PG. So I think the first question was, should the PG bouncer be used for replication connection?
Yes.
Yeah, you shouldn't be using PG bouncer for your replication connection. You can just directly make connection to your primary database using the primary coninfo and provide the IP address of your primary database there. So what was the second question?
Are there any type of connections that should not use a connection pooler?
So I would say the super user should not be using connection pooler. because they want direct access to the database. And then if you're running any kind of backup recovery commands, you should directly use the super user connections and connect to the database directly instead of going through your connection pooler or load balancer.
All right. Another question we had was, can pgpool use pass-through authentication?
pgpool doesn't use pass-through authentication, so you have to maintain a pool password file for uh, all your users that are going to connect using pgpool. So again, these connection poolers are useful when your application is connecting using the same username to the same database. Then it can reuse the connection. Okay, so if you are using hundreds and thousands of users, and every user has its own using its own username, then basically connection pooler will be opening and closing connections all the time. And then you will also reach the limit, and then your connections will be queued. So it's mostly useful when you have a low number of users that connect to the database, and those connections can be reused with the same username and database pair. Okay, but pgpool does provide a pool HBA where you can use other type of authentication such as MD5, PAM, or some other Scram. So all those authentications are available in the pool HBA file, as the same type of authentications are available in Postgres PG HBA file.
Alrighty, okay, good to know. Another question we had come in was, if using pgpool running on the app server, how does it manage multiple servers connecting with the same ID?
So if pgpool, can I see the connection?
Sunil, it's in the chat, so you can actually read the questions in the chat, and then we also have a couple of questions in the Q&A.
Oh, okay, okay.
Section too, but this particular connection is from Suzette in the chat.
Suzette, if using pgpool running on the app server, how does it manage? If pgpool running on the app server, how does it manage multiple server connecting with the same ID? If using pgpool running on the app server, okay, how does it manage multiple servers connecting with the same ID? So same ID meaning same user ID. So as long as you have the user ID and that user ID is connecting to the same database, and if pgpool can find that user ID and database connection in its cache, it will reuse that. If it doesn't find that, then it will open a new connection. But if you have already reached the max connection limit, then your connection will be queued. And then once a backend connection is freed, then your connection will be open. So you control that by the max pool settings. And by default, that is 4. So at a time, it can cache 4 connections, but you can increase it.
Sunil, there's also a clarifying question that Dennis McCracken asked in the Q&A.
Yeah.
He says, I believe I heard you assert that PG Bouncer should be limited to 30 connections per instance. What do you base that assertion on?
So there were some benchmarking, and I will find those blogs and send it to you. So PG Bouncer, there was some benchmarking done, and it was found that if you want to use more connections, run multiple instances. Don't try to run everything through one PG Bouncer. Otherwise, you will see the bottleneck.
Great. Thanks, Sunil.
Great. All right. We do have one more question. So if there's anyone else in the audience who would like to ask anything, this is your chance. Please start typing your question. Otherwise, this will be the last question. And this question is, what did you mean when you said load balancing of read queries can be unreliable?
Okay, so yes, this many times we have found and through our support cases and customer issues that sometimes pgpool doesn't route the queries right to the right server. And then, okay, I'm not sure what happened to the Q&A. Yeah, so that's the reason. If your application can identify that read queries can go to the read connection and write queries can go to the write connection, that will be much more reliable. The other thing is, if you're using a JDBC driver, and JDBC driver also provides the load balancing and query routing. So Postgres JDBC driver, if you are using a Postgres JDBC driver, then use the target type parameter and open two connections, one for read-only workload, one for read-write workload, and use that in your application, so that you are not relying on pgpool to make that determination whether or not send a read query to the read replica. You are basically deciding yourself, and that is more accurate. The other advantage is you are not dealing with the overhead that pgpool adds, because it has to inspect each query that is coming and then decide, whether or not it can be sent to the read replica, or whether it should go to the read-write or primary database.
Alrighty. We had two more questions come in while you were answering that, and we do have time for them. So the first one was, can PG Bouncer be run on a separate server rather than on the application server?
Correct. Yeah, you can decide to run PG Bouncer anywhere. But if it's running on the application server, you don't have to deal with the network, any kind of network delays connecting to PG Bouncer. But you can, if you think that PG Bouncer maintaining a component on your application server will add some overhead, then please run it on a separate server. But PG Bouncer is a lightweight connection pooler. It doesn't add too much overhead.
Okay, so then our last question is, can I use a single PG Bouncer for two different clusters? And then it looks like there's follow-up to the statement in the Q&A.
Okay, so can I use a single PG Bouncer for two different clusters? I haven't done that, but technically you should be able to do it, because in the database sections, if you see, it just needs the name of the database and the host of the host address. Okay, so if you use a different host address, you can define multiple databases there, and then it will open a connection pool for that database. Okay.
All right. All right, that looks like all the questions that we have for today. So thank you, Sunil. Thank you everyone for joining us for this webinar. We will be sharing the recording along with the slides with you as soon as possible. And I hope you all enjoy the rest of your day. Thank you all for joining. Thank you.
Thanks, everyone. Bye.
Bye.